In this video, we'll be looking at the laws of logarithm. And if you have not subscribed to this channel, kindly subscribe so that you'll be the first person to be notified when a new video is being uploaded. Let's get started. So the first law is what we call the product law. Product law is saying that if you have logarithm of a, logarithm of x to the base a plus logarithm of y to the base a. Now this is what we are saying. Provided a is not equal to 1 and a is not negative, that is, we're referring to the base, not equal to 1 or negative, and then x and y are not negative numbers, then we can write them as logarithm of a. This is based on the fact that the base are the same, that is a, and then at the same time the logarithm are being added. Then we have log to the base a, and then we have x, y. So we are going to multiply the argument x and y, and then write one of the bases based on the condition that the logarithm are adding. So that is that. So example, we can think of logarithm of the argument 5 to the base 3 plus logarithm of 7 to the base 3, and we can see that they have a common base of 3 and then they are being added. So we can write them as logarithm of 5 times 7 to the base 3, and we know 5 times 7 to be 35, which means logarithm of 35 to the base 3, and that becomes our solution. We can also have the vice versa. If we have logarithm of 4 multiplied by 3 and they have a common base of 2. Now once they are being multiplied and they have a common base, then we can expand and write them as logarithm of 4 to the base 2 plus logarithm of 3 to the base 2. And that is the product law of logarithm. Now we move to the next law, and the next law is what we term as the quotient law. Now the quotient means dividing, which means we can have a logarithm of x to the base a minus logarithm of y to the base a. Now with this, provided they are to the same base and they are being they are being subtracted, then we can write one of the logarithms of that same base, and then we divide the argument, that is x divided by y, based on the condition that they have the same logarithm and at the end they are subtracting. So we can have an example. We can think of logarithm of 15 to the base 2 minus logarithm of 3 to the base 2. So with this one, we can see that they have the same base and then they are being subtracted. So with this, we write the logarithm to the base a to the base 2, and we divide the argument, that is 15 divided by 3. And we know 15 divided by 3 to be 5. So that means, let's write this one well. Alright. So that means we're going to have logarithm of 5 to the base 2. Now we can take the vice versa. If we have logarithm of 8 divided by 2 to the same base of 10. Now we can see that they have the same base and they are being divided. So we can rewrite it as logarithm of 8 to the base 10 minus logarithm of 2 to the base 10. And with this, we are doing it based on the fact that the logarithm here was being divided, and we can write it at this side as minus. This is when they have the same basis. If they don't have the same base, we cannot write it as such. Now we move to the next law, and the next law is what we call the power in this law. That is the law 3. Now we are saying that if we have logarithm of x exponent n to the base e, Now, this means that we are taking the exponent of the argument x and rewriting as the coefficient of the logarithm. So the exponent of the argument here is n, and we are going to write this n as a coefficient of the logarithm, which means we are going to write this as n logarithm of x to the base e. So this is the exponent, now a coefficient to the logarithm x base 8. So example, we can think of a number like logarithm of 3 exponent 2 to the base 4. Now with this, we can rewrite 2 or rewrite the whole thing as 2 logarithm of 3 exponent 4, knowing well that the exponent now is now a coefficient at the right hand side of the logarithm. So this is that. Now we can write the vice versa. If we have half logarithm of 6 to the base 5, now this can be written as, now the half now is the coefficient to the logarithm 6 base 5, which means the coefficient can now be raised or can now be an exponent to the argument 6. That's the vice versa of the power index law, which means you can have logarithm of 6 to the exponent half, and then it has a base of 5. So that is the power index law. Now, having known that, we go to the next law. That's the last one. That's what we call the change of base. Change of base, which means we are going to change the base of the logarithm. If we have logarithm of x to the base e, now this is how the change of base work. We are interested in changing the base to a different base. Now, we mostly do this when we have a question and that question demands the change of base. So we can change the base a to a preferred base, like I'm interested in changing the base a to a base b. So if I change the base, then our logarithm is going to be written in terms of logarithm of x, and also the base a now becomes a logarithm, that is an argument, which means we're going to have logarithm of a, and then you give the same base to it, that is the base b. So better still, if we have logarithm of y to the base m. Now if you want to change the base, then we can have logarithm of, so maybe I want to change the base to the base p, so have p here, and then the y comes as an argument divided by logarithm of the base that I want to change, that is p, and then the m becomes an argument m. So we can have examples, and example, we have example like logarithm of 8 to the base 2. And so with this, we are interested in changing to a preferred base. Sometimes we do this based on a particular question following a particular trend of base. So we want to change to a base 5, which means we can have a logarithm of 8. Now the base we want to change now is 5. In the same way, we are going to have logarithm of 2, which means this 2 now is not a base anymore, but rather an argument 2. And then the base that we said we are going to change to is 5. So that is it. We can take another example, and we can think of logarithm of 4 to the base 3. Now, to this logarithm, we want to change to a base that we want. So you can think of a base 2. So we can have 4 here. We want to change to a base 2, which means we can have logarithm of 4 to the base 2 divided by logarithm of 3 to the base 2. And that's how the change of base works. Now, having known this, we can try an example, a practical illustrative to this laws of logarithm. Now, exercise on the laws of logarithm. So the first one says that write logarithm of x to the base 3 plus logarithm of 5y to the base 3 as a single logarithm, which means we are going to apply the laws of logarithm here. So we have our solution as logarithm of x to the base 3 plus logarithm of 5y to the base 3. And with this, what you can do here is that you can apply the laws of logarithm, and we are seeing that if they have the same base and the logarithm are adding, then you can write one of the logarithms and then we multiply the argument, which means we are going to get here as x multiplied by 5y to the base 3. Now we can simplify it and have logarithm of the argument 5xy to the base 3, and that becomes our answer. Now let's try the next question, and with the next question we have express logarithm of 2m base 4 minus logarithm of x base 4, and with this we are going to write it as a single logarithm, which means we can have our question as logarithm of 2m to the base 4 minus logarithm of x to the base 4. So from the laws of logarithm, we say that if you have a logarithm and we can see that the logarithms are subtracting, we can write it as a single log by knowing well that the logarithms are going to divide. And so simply put, then we can write it as, which means it's going to be equal to, now since they have the same base, you can write one of the bases as 4, and at this point we divide the argument, that is 2m divided by x, and that becomes our solution to this question. Now let's move to the next set of questions, and the next set of questions we have write logarithm of the argument 6x exponent 3, 6sy exponent 3 minus 2 logarithm of logarithm of 3x y squared z to the base e, knowing well that the logarithm of 6s y exponent 3 has a base of e as a single logarithm. So we want to write this as a single logarithm, which means we have logarithm of 6xy cubed minus 2 logarithm of 3x y squared z to the base e and to the base e. So as a single logarithm, then we are going to break it down. We can see that there is a common base here, and then the logarithms are being subtracted, which means you can write it as a single logarithm by dividing. But before that, we can see that there is 2 logarithm a, 2 logarithm to the base a, which means we can write this coefficient as an exponent to the argument. So to put it into practice, then we have logarithm of 6xy cubed to the base e minus logarithm of 3xy squared to the base 3xy squared z, all having an exponent of 2, which means the coefficient is now coming to be an exponent here to the base e. Now we can further simplify, and we have logarithm of 6xy cubed to the base e minus logarithm of e, logarithm to the base e, logarithm to the base e, and when we expand 3xy squared z all exponent 2, we are going to have 9x squared y to the power 4 z squared. So further we continue, and we have logarithm of, now we are going to write a single logarithm, and we have logarithm of e, that's logarithm to the base e, logarithm to the base e, and we have 6xy cubed divided by 9x squared y exponent 4 z squared. So if that continues, then you can put it in brackets. Now we can see that 3 can go into 6 and can go into 9, which means we have logarithm of e, and when 3 goes into 6 we have 2, and when 3 goes into 9 we have 3. Now we come to the x part. You can see x is going to cancel itself and goes into x squared 1. So it means we have 3x here. And y2, the y cube is going to cancel y to the power 4. And we have 1 y left at the denominator. And then since there is no z at the numerator, we maintain the same z at the denominator. And this becomes our solution to the question. Now we try the last question, and we have this one. It says express logarithm of m all square root of x squared y cubed divided by z exponent 4 in terms of logarithm of x, logarithm of y, and logarithm of z. So with this, we have our solution as logarithm of square root of x squared y cubed divided by z exponent 4 all to the base m. Now with this, we are going to apply the laws of logarithm. And with this one, now square root can be written as half, which means you have logarithm of m x squared y cubed all out of z exponent 4 all exponent half. Now we can write this exponent as a coefficient to the logarithm. That means you have half logarithm of m, and we have x squared y cubed z exponent 4. Now by applying the laws of logarithm, there is a division sign here, and it's been written as a single log, which means we can expand the logarithm now, and we have half logarithm of m and this logarithm of m is going to have x squared y cubed as the argument and minus logarithm of z exponent 4 to the base m. Now if that continues, then we have here as half. Now we can see logarithm of x squared y cubed to the base m, that we can see x squared y cubed, they are multiplying, which means we can write them by expanding. So we can have here as logarithm of x squared to the base m plus logarithm of y cubed to the base m minus logarithm of z exponent 4 to the base m. Now having known this, then we continue with our solution. And at this point, you can see that every logarithm here has an exponent, of which these exponents can be written as a coefficient of the logarithm, which means we have half here. And with the first one, we can write it as 2 logarithm of x to the base m plus 3 logarithm of y to the base m minus 4 logarithm of z to the base m. Now having known this, then we can see that the half is going to multiply through the logarithm or the expression we have here, which means with the first one, we're going to have half multiplied by 2 logarithm of x to the base m plus half multiplied by 3 logarithm of y to the base m, and then the last one minus half multiplied by 4 logarithm of z to the base m. Now if that happens, then our solution now becomes this 2 is going to cancel that 2. So you have logarithm of x to the base m plus 3 out of 2 logarithm of y to the base m minus, so we write it well, and we have minus, now 4 divided by 2 is minus 2 logarithm of z to the base m. And this becomes our solution to this question. So this ends today's video. Thanks for watching. Kindly like, comment, subscribe, and share. This is BakoMaths, thinking beyond infinity.